We can use linear trend forecasting to predict an increase or decrease in sales or population data linearly over time. For example, you can see here Texas population data for the period 1996 and 2016, which is given on this table. We can show the data on a chart to see the time trend. To do that, we select the data, including the date and the population data, and then we go up and insert the chart. The kind of chart we are going to use is an XY scatter chart. And we select the type of chart with points to see how population data looks like through the time. Now here you see that we have just charted the points of the population data through the time, and we don't have a trend line yet. The chart in Excel will find a trend line. What we do to get the trend line is to click on this plus sign on the chart, and it brings up the new menu that we can add a trend line. Next, we will find the regression equation. And to do that, we are going to use Analysis Toolpak regression option. Here you need to be careful. We need to create a continuous time variable by numbering the years consecutively as 1996 being 1, 1997 2, 1998 3, and so on. Let's call this new variable as trend. In this scatter plot, population data is plotted on the vertical axis, and the trend variable is on the horizontal axis. You can see that Texas population increases over time. As you may realize, all observations fall on a single straight line. The simple linear regression for population as a function of trend variable can be written as following. Population is equal to A is the intercept parameter, plus B times trend. B is the slope parameter. So A is going to show where this line intersects with the y-intercept, and then B shows the slope of this line, trend line. We will use simple linear regression model to estimate the parameters of A and B using population data and trend variable that we have created. In this example, population data is the dependent variable. Trend variable is the independent variable and is denoted by X. In order to estimate parameters, we will use Analysis Toolpak in Excel. We go up to Data tab. We select the Data Analysis Toolpak and select the regression option of those given choices. Hit OK, and then regression option brings up the regression dialog box. Y range is where we enter the dependent variable. Here in this example, it is population data. So we are going to select the population data with its label. X range is the independent variable, that is the trend variable in this example. We select the data along with its label. Since we have selected the data along with its label, we will check the labels box on the screen. We are going to check confidence level 95%. We also need to keep constant is 0 box unchecked. This will estimate the intercept parameter of A for our regression equation. And then we will choose the output range. Let's say I'm going to randomly choose A32 here. And then we click OK. And this will run the regression in Excel. I'm going to highlight intercept and slope parameter estimates. So as you see, we found intercept estimate as 18.51 and slope parameter estimate as 0.446. So using these parameters, we are going to write our forecasting equation. $18.51 is the intercept, plus 0.446 is the slope, times trend. So when we look at our data table, you realize that our data set ends in 2016. In order to forecast the data for 2017, 18, 19, 20, and 21, we need estimates of both intercept and coefficient of the trend. So let's start finding our forecast. First, for the historical data. So I'm going to use the intercept term, estimated one, plus 0.446 is the slope. And the trend variable for the first period, which is for 1996, is 1. And for the next year, I'll do the same. The intercept term is 1851, plus slope times the trend. But this time, trend variable is 2. And then we will find the forecast for 1997. And we can drag down the formula. So we forecast all historical values. Next step is to find forecast for the next 5 years. To find forecast for the next 5 years, we need to extend the trend variable until 2021. And here, I'm going to use the same regression line to forecast future population data. But trend is going to change. It's going to be this time 22. And then you can drag down the formula. So you have forecast for the next 5 years. And we can plot the data, actual population, and the forecast to see how we accurately forecast. To do that, we select insert here. And then you can choose line graph. And then select data. We want to add first actual population. And we have actual data from 1996 to 2016. I'm going to include the data set until 2021 to compare actual and the forecast. And next, we will add forecast. And we can edit here the years. And now you can see the graph of actual and forecast. Since actual and forecast are so close to each other, the lines are overlapping. So let's summarize what we have learned in this video. First step, we scatter plot the data and time. Second, we create a trend line and use regression option to estimate the regression line. Third step, we write down the slope and intercept terms of the estimated regression equation and use these parameters to forecast. And next, if you want, you can calculate errors, or we call it residuals if you remember, for the regression model. As you know, the errors are calculated as the difference between actual data and the forecast. So this will help you to find root mean square error. Let's find squared errors. And then average them, mean squared error. And get the square root of average. And finally, we calculate root mean square error, and that completes linear trend model.